having looked into the other process of a concrete production, namely the mixing, batching, transportation, placing, last of it, that is the curing, the most important part, will be looked after today. Today we shall look into curing. This is the most important. Quite often people tend to ignore this, but this is most important, as we shall see in a short while. Also we will discuss about prefabrication. Right. So, let us see what is going to be our general outline of our discussion today. First of all, we will look into curing, as I mentioned, then we will look into what is the need of curing essentially, and then we will look into details of various methods of curing. In prefabrication, we will look into the process and we will mention about something called modular coordination. So, let us look into curing. Why do you need curing? Now, if you remember, when we talked about cement, we said that it's it's produced from lime and clay, burning both of them together. Now, such material when burnt together forms a kind of solid solution, about which we will discuss later on, and we said that when you mix water with it, there is a reaction, and we call this reaction as hydration reaction, and then through this reaction it becomes solid. Now, this reaction is never instantaneous, it takes time, and therefore, this reaction, since it takes time, the condition must be conducive for reaction to continue. Now, this reaction, since it is a reaction with water, it can take place only in presence of moisture, that is vapor. In other words, in case of the 100% relative humidity in the pores of the cement paste system is required for this reaction to continue. So, hydration takes place at only at 100% relative humidity. Now, when you mix water with the cement, what happens is, since the reaction is not instantaneous, only a part of this water reacts, rest all remains there. But if you expose it to atmosphere, most of it will evaporate. So, there is a loss due to evaporation. So, there is a loss due to evaporation. So, therefore, the 100% relative humidity condition will not be maintained, that is the saturated pores will not be saturated with moisture unless you replenish the water that has been lost by evaporation. Besides, chemical reaction of cement with water also consumes some amount of cement. So, supposing I stop the evaporation process, even then there will be some amount of loss of this moisture due to the chemical reaction of cement with water, because some of the water will be consumed, and that we call as self desiccation, and it is actually internal loss of water, and we must replenish this water if the pore has to remain saturated with moisture vapor. So, therefore, these are the basically the needs. Now, sometime it may be also needed to maintain a temperature, because you see the concreting at very high temperature is not desirable. We do not want to concrete at a very high temperature, or even after you have cast the concrete, we would like to control the temperature, especially in tropical areas or hot conditions, hot and dry conditions, hot conditions particularly, and there we may have to maintain the temperature of the concrete through replenishment of water or by supplying water. So, curing therefore is needed to continue the hydration process, to rather avoid loss of water or reduction of this relative humidity. So, what do? We actually add water to it. So, curing is a process in which we add water or prevent the loss of water from the concrete or cement paste or whatever it is, or the similar sort of thing. Right now we are mostly talking of the cement paste loss of water, although its concrete has got mainly the water will be lost reacted with the cement, because aggregates, as I mentioned earlier, they are inert. So, cement paste to which actually water reacts, that consumes some amount of water, other water is lost by evaporation. So, this water has to be replenished or supplied from outside, and its evaporation loss should be restricted. So, this process by which actually we prevent loss of water through evaporation or drying of concrete, and also supply additional water to replenish the loss of water, that process we call as curing, and it takes place over a period of time. So, we have seen the needs of curing and also how we do it. One more additional important point related to curing is, you see, as we shall see in one of our later lectures, that hydraulic cement when reacts with water, since all water do not react instantaneously, some of the water will evaporate. We replenish this water, all right, but the space that was originally occupied by water, it has to be gradually filled by the product of the reaction. Now, this takes time, it takes days, months, and up to even a year or more. So, this space which was originally occupied by water must be filled in by the reaction product. Now, this only can occur if curing is taking place or the reaction is taking place. Curing is being done and reaction is taking place. Now, if I do not cure it, the space that was originally occupied by water, that will remain as capillary pores. Capillary sized pores, sizes we will discuss later on, but they are capillary pores because water can enter there by capillary suction. Now, these capillary pores will allow water to come in, and as again we will see later on that most of the degradation process in case of concrete is due to ingress of aggressive chemical agents from outside, mostly through water. Therefore, these pores, their presence is harmful from the point of view of long time durability of concrete. The capillary pores that is formed by the space occupied by the water that has not reacted in the long run, this pore space allows water to come in and therefore allows aggressive chemicals to come in, which we shall discuss again, and therefore, they are harmful to long term durability. So, if you do curing, sufficient curing, this capillary pore space will be filled up, but even though if it is not filled up, at least they will get segmented and will not remain interconnected. So, segmentation of the pores, that is separation of one pore to another pore, that means they should not remain interconnected, is most important from durability point of view of concrete, right. Durability point of view of concrete, this is capillary segmentation, this is very, very important. Capillary segmentation is very, very important from durability point of concrete. So, as you can see, for strength development, one thing is for the curing is necessary to prevent loss of water, and this in the process actually hydration reaction will take place, and this will actually ensure that capillaries are segmented and strength development and properties development of concrete is possible. So, that is what is the need of curing and importance of curing, right. So, next look at the next slide. If I do not do curing, then what will happen? Just let us look at them. First of all, since pores are the inherent flaw in the structure of concrete, this will be explained in detail later on when we talk of strength of concrete. Therefore, if I do not reduce down these pores, strength will not be proper, adequate. So, it will result in poor strength development. This will result, so poor curing will result in poor strength development, right. Then, if I allow water to evaporate from the concrete surface, what will happen? It will get dried up, and when concrete dries, especially in the early stage, even later on of course it can take place. So, drying of concrete can result in its shrinkage. Phenomena of shrinkage we will look in details, but let us understand for the time being that drying, when it dries, it will shrink, it can shrink, and this shrinkage, since the surface dries, maybe the inner core inside the concrete specimen, it may not dry so much. So, there can be differential shrinkages, top shrinks more, bottom does not shrink so much, resulting in formation of cracks at the surfaces. So, drying shrinkage cracks can come if you have allowed the top surface to dry rapidly, and to prevent that, again we do the curing or replenish the water at the surface, especially in the early age. Once things have become stable and the capillaries are segmented, well, the water, like the drying effect would be relatively less. So, in the beginning it is important that we avoid drying shrinkage and could result in crack, and therefore, if we do not do curing, this can actually result in drying and result in shrinkage, and this might be aggravated by thermal effects. For example, in a hot arid sort of climate in the northwestern part of the country, India, we have high ambient temperature, low relative humidity in summer, very low relative humidity. In a hot dry desert sort of climate, you may have about 40% relative humidity even in the morning, and in the peak temperature time it may be 10% or so, and the temperature could be as high as 40 plus. And in such a situation, if you have not replenished the water or not at least covered the surface of the concrete, it will quickly dry off, and both shrinkage and even shrinkage cracks can result in formation of defects in on the surface of the concrete. So, this is important issue. If I do not do curing properly, I can have drying shrinkage cracks. Sometimes they are only fine cracks crazing at the surface, but aesthetically they are poor. Sometimes in thin sections they can be through and through cracks because of drying shrinkage, very thin sections, drying shrinkage cracks can be through and through. Of course, there are other ways of actually tackling these cracks, but curing is it helps in preventing such sort of crack formation. Now, last one I mentioned earlier, that if you do not do curing, if you do not do proper curing, the capillaries will not be segmented, they will remain interconnected, and interconnected capillary pores are not good for long term durability of concrete, because water can come in through these pores and result in deterioration of the concrete, along with some aggressive chemicals water will come in. So, interconnectivity of the capillaries in concrete system should be prevented, and that can be done by segmentation of the capillaries through proper curing. So, curing, of course, there are other means, but curing is also helps in segmentation. One must remember that if you do poor curing, there could be no segmentation, and therefore, it may result in poor durability of the concrete. Right. So, let us see diagrammatically what happens, how this strength development issue. So, people have done experiment, past experiments have shown that the strength development of concrete takes place in this manner. Say, let us look at this. So, if you keep continuously in air, this is the curve, continuously in air. See, this side is the composite strength of concrete in MPa, this is same thing in PSI, and this is the age. So, with age you see the strength of concrete increases, but if you do not replenish this water, the strength do not increase beyond a point, in fact, it will have a slight decrease. Now, you do curing for 3 days. So, you can see that initial, of course, the strength here also 7 days strength increase takes place, just keeping continuously here. So, some amount of loss would be there, but it would be dependent on the type of test that was done. So, in a specific case it is shown that actually temporary, it increases up to about 14 days, and after that is steady, but it would depend upon what is the condition of the air, what is its temperature, what is relative humidity, is there any wind and things like that. So, in a very dry condition, high temperature, this may not be even this much, there may be much less reaction, and therefore, but then qualitatively this is fine. Now, see this case, the same concrete, when it was kept in water for 3 days, that means you have done a moist curing for 3 days, then it has shown an increase in strength much higher, even in the same time much higher strength increase. Then of course, beyond that it again showed reduction, and so on and so forth. And if I keep it for 7 days, it is something like this. If I keep it for 14 days in water, that is, I am curing for 14 days, for 28 days, this is how it is. So, you can see that more the number of days I keep it in water or I cure it, actually there is an increase in strength development. Now, if I keep it continuously moist forever, so here I started, I kept it for 28 days, beyond that I put it in here. There is a slight increase after that, the strength increases slight, but then finally it decreases. But if I keep continuously in moist condition, the strength will go on continuously increasing. Of course, you can see that this is asymptotic to certain value. I mean, it is just not infinitely increasing or something of that kind. Okay. So, what happens when you are continuously in moist condition? There's, of course, there could be some sort of redistribution and little bit of more hydration or reduction of the porosities and pore sizes, slight increase in strength, and therefore that is a reduction. So, what we see from, and this was for water cement ratio 0.5 concrete. For another water cement ratio, the strength exactly will not be like this, and you can see the relative strength. This was about 40 MPa, close to 40 MPa when you have done a curing for 28 days. So, ultimate strength, the maximum strength attained was 48 MPa. And if you keep it for continuously moist, the maximum strength attained is something like about 22, 3, etc. If you keep it for 7 days, it is somewhere around 30, somewhere around 32 or 33. So, this is the relative ratio of the strengths that one attains, one can get when it is cured. So, for another water cement ratio thing could be different, but qualitatively we understand that if the more the days of curing, I get the long term maximum strength attainable is higher. We are of course mostly concerned with 28 days strength, because concrete is specified in terms of 28 days strength. So, generally this idea is kept in mind while specifying the number of days required of curing, right. So, that is what it is. It says how the strength development is actually governed by curing conditions, right. Now, let us look now into, so what we have understood so far, what is curing actually, what is the need of curing, and how curing helps in strength development, and what happens if you do not do curing, etc. So, let us now look into methods of curing. Right. So, since we are supplying water, one method obviously would be using water or moist curing, using water or moist curing, right. But that can be done in several ways. We can do it by ponding, we can do it by spraying water onto the surface, we can do it by covering with wet sand, wetted Hessian clothes or absorbent covering. So, we can use moist curing, so we can use in different ways. Ponding is very suitable for flat surfaces, let us say a bridge deck or even a slab, roof slab or floor slab. So, what you do, you put sort of a barrier at the boundary of the flat surface and just pond this surface with water and keep it ponded for the time you desire, and that is a very good way of doing curing, especially for flat surfaces. If you can't pond, you do not have that much of water, of course, you will have to go for some other sort of way, and water might evaporate at a very fast rate, then ponding becomes also difficult. So, in such situation you can do something else, you can cover it with wet sand, or sand, if it is drying off, spray again water, sand will hold on to the water for a longer period of time, and then you repeatedly periodically you go on wetting that sand, and that is what is this. Then wetted Hessian or absorbent covering. So, you have put some sort of gunny bags, for example, old jute gunny bags or similar one which can absorb the water, which can keep the water in position, some jute or similar sort of thing, cotton waste or Hessian, was the old gunny bags were used very often. So, wet them, keep them over the surface, and this can be done not only for the horizontal surface. Sand is of course for horizontal flat surfaces, but Hessian can be done for vertical surfaces as well. So, for example, in a column you wrap up the Hessian or gunny bags of the older kind, and the cement bags, those were jute bags those days. So, one would actually wrap it around the column and spray water to sprinkle water onto it, keep it wet all the way for the required number of days. Spraying is also useful in some cases, for example, where you can't use wet Hessian. That's very effective way, wet Hessian or something of that kind. Sometimes you can spray. For example, in an automatic precast factory, I will talk about precast or prefabrication later on. In precast factory, one might have sprinklers to continuously spray water onto the precast elements. So, you can have such sort of situations, continuously maintain 100% relative humidity by spraying water. Spraying water can be done even otherwise, many places spraying of water is used. You have small pump through which you can just spray water or sprinkle water onto the surface. So, this is the other method, right. Now, that you can do provided you have sufficient water available. If you do not have water available, then what you do? At least you can do is you can cover the concrete. First of all, prior to setting, that the curing does not start till the concrete is sort of solid. So, it has to be solid, after which you start sprinkling water. But even in its plastic or watery condition, slightly soft condition, plastic condition, not solid condition, the water can evaporate. So, you can cover the surface, so that no moisture can evaporate from the surface of the concrete. Then keep the formwork, the mold. We discussed about the formwork earlier. So, we said that we put into the mold and get into the right shape for the concrete specimen or concrete element, and you can keep the form. For example, for a vertical member, you can keep the side shuttering on for certain longer period of time if you think that you can't do curing. So, this will ensure that there is no loss of moisture from those surface, but remember, you are only blocking evaporation loss, you are preventing loss due to evaporation. What about self desiccation? That water will still be consumed by the concrete internally. So, relative humidity will not be 100%, it will not be as good as spraying water or replenishing the water, but it would be better than not having anything, right. So, you can retain the form, cover the concrete, and then there is something called membrane curing. Now, you see, membrane curing is again where you have lack of water. Also, it is also used in precast industry, like a metro construction that was there in that's going on, or that was going on in Delhi, and in their precast elements they were using this. So, many similar precast situation one can use this membrane curing. So, it could be either spray or hand applied, that is through brush, some sort of a coating like thing, usually could be resins or waxes, which will prevent loss of moisture from the surfaces. So, one has to be, these are actually chemicals or waxes or resins, as I said, they are applied onto the surface of the concrete to prevent evaporation loss. But remember, their temperature stability has to be seen. They should not melt away or peel off from the surfaces because of the effect of the temperature. The curing compound, as they are called, which might be effective in, let us say, a cold climate of Europe, may not be effective in tropical climate. So, one has to be careful about such thing, because tropical climate, the temperature at the surface, effective temperature, what we call soil air temperature, because of the radiation coming onto the surface of the concrete in addition to the surrounding air temperature, can be as good as 60 degrees centigrade. So, in northern Indian, say, dry summer season, it could be as good as that. So, in such situation, if your curing compound is not stable, it will not be effective at all. So, one has to be careful and cautious about such curing methods one being applied. The compound has to be chosen appropriately. So, membrane curing is the other kind. It is also again not replenishing the water, but essentially what it is doing? It is actually preventing water loss. Where you have no way, you are not getting water, in desert, say, this could be a good useful thing, provided you have taken care of the situation of the temperature. Second aspect is, it is quickly you apply and leave it there. So therefore, you can you do not have to employ people for long term curing. So that is an advantage, quickly you can apply, and if you have taken care of it in design properly, you have taken sort of cushion for lack of strength development and so on properly, it can be used. So depending upon the situation, this can be used, this can find its use. If possible, there is nothing like better than moist curing. Okay. So that is it. Then you can have plastic sheet covering, polythene covers. You can use polythene covers or something of that kind in order to prevent loss of water. Where you have no water, what to do? You use either the membrane curing compounds or waterproof plastic sheeting. So that is the other way of doing. Another way of curing is using steam, because from Leach-Atelier's principle, the chemical reaction, this particular chemical reaction, which is exothermic in nature, is favored by high temperature condition. Now, steam is at higher temperature, when cement reacts at a faster rate with water at higher temperature. So, steam curing is again keeping it 100% saturated, relative humidity remaining 100%, and ensuring that temperature itself is also high. So, that is what is steam curing. Now, that can be used if you want quick strength development, early strength development. You want to release the molds, or you want to do pre-stressing or similar situations where you want early strength development, steam curing is used, because you can attain the same strength, early strength by doing this curing. So, steam curing is used specifically in certain places where you want early strength development, right. So, we will look into details of steam curing a little bit more, because that process we should see. Now, let us see what happens for the effect of moist curing. Okay. Now, this is for cylinder compressive strength against water cement ratio. This side is water cement ratio, and you can say this is ponded. This is ponded. You can see that this is this line, this corresponds to dotted line corresponds to ponded, that is this one is ponded, and the thick lines, this one corresponds to the Hessian. Now, ponded is a continuous supply of water, there is 100% water there. Hessian means, well, it would become dry and then you make it wet again. Now, it has been observed that this result is 1 day result, this is 3 days, and this is 28 days results. The cylinder compressive strength when plotted against water cement ratio, ponded tends to give you always higher strength than the Hessian, and this difference increases with the age. So, 1 day age, you see this difference is relatively less, and it is, but what happens when you have high water cement ratio, these effects are relatively less pronounced. At high water cement ratio, these effects are less pronounced, because after all very high water cement ratio, this is somewhere around 0.42 or 0.43 maybe, somewhere around that kind of situations. Well, ponded and Hessians tends to give you same, because there like the capillaries would be relatively more, and generally the effects of curing by ponded and Hessian remains same. So, we can see that ponded is better, especially when you have low water cement ratio, but anyway any case ponded means 100% replacement of water. Hessian is quite good. So, this idea one can use. Commonly Hessian is used in vertical surfaces and also on horizontal surfaces, but it is okay, it is still whatever is possible one can do, both would give you equally good results. Right. Now, let us see other methods. I mentioned to you curing by formwork, covering with membranes, and all this would actually covering formwork and covering with membranes, etc., covering with these coverings, membranes, formwork, all this actually stops evaporation loss, but do not replenish the moisture loss due to self desiccation. So, they can be as good as the moist curing, right. Okay. So, that is I have mentioned already and explained. Now, the code specifies the minimum number of curing days. Code specifies minimum number of curing days, because as we shall see, higher the number of days of curing, you will have better strength development, and also segmentation would be is other criteria. Also initially few days you must do curing, otherwise drying shrinkages, cracks might appear. So, based on these considerations, the code specifies number of days of curing. Now, it has been seen that for segmentation of the capillary, the number of curing days required is a function of water cement ratio as well. For example, with water cement ratio 0.4, when you have, because 0.4 means less water filled space in the beginning. So, less capillaries to start with, because it is the water, excess water which does not react, that forms the capillaries. We will come to this again and again, because this is very important from the point of view of concrete. So, higher the water cement ratio, more will be the capillaries, and therefore, you require longer period of time to segment these capillaries. So, you can see that with water cement ratio 0.4, you need only 3 days for capillary segmentation, whereas with water cement ratio of 0.7, you need about 1 year of curing to segment this capillary, because you have large amount of capillary when the water cement ratio is so high. When your water cement ratio is so small like 0.4, in fact below 0.4 you would require very little, because there is a capillary pores would tend to be 0 at much lower water cement ratios, as we can see theoretically we will derive this, we can derive this actually. So, segmentation, therefore, curing days for segmentation would depend upon the water cement ratio as well, right. All right, but then you can't develop practices or recommend practices based on this kind of details. The code gives you simple formulas, or as per IS 456 Indian Standard Code of Practice, IS 456 2000, it simply gives you number of days required for curing. Okay. So, that is it, and then additional information, one more thing. When we talked of cement, we talked of some others, when we were just introducing concrete, I said there are admixtures, and the admixtures are the kind of chemical admixtures, and the other kind of admixtures are the mineral admixtures. Now, these mineral admixtures we call them pozzolanas, perhaps this was mentioned earlier, we will come to this again in relatively more details. Now, this pozzolanas are actually pozzolana. These are materials, silica, essentially SiO2 silica, which can react with lime, forming same product as cement with water, similar, not same, similar product as cement and water. Now, this reaction however is relatively slow. This reaction is relatively slow compared to that of cement and water. Okay. And not only that, when some amount of this material is used in conjunction with some amount of cement and then add water to it, cement itself produces some amount of lime through its chemical reaction. Again, this will be discussed, we will talk about it, and this lime can react with the pozzolana. Now, this reaction is a slow process. So, this requires longer time, more number of curing days for strength development. This requires more number of curing days for strength development, and therefore, our code suggests following values: 7 days for ordinary Portland cement, no blending; 10 days for blended cement, that means where you have used pozzolana together with the ordinary Portland cement clinker, or you have used mineral pozzolanic admixtures. But it does something more, it says if it is a dry and hot condition, corresponding periods should be 10 and 14, because evaporation rate will be higher, and therefore, it gives you higher values. Now, British code of course goes in a slightly more elaborate way, but does not matter. I think we are concerned about the Indian codes, other codes, some other codes, it gives some formulae etc. Well, that is not our concern at the moment, but Indian code does it in this manner. So, that is how based on the need of curing, the codes do it in this manner. Now, let us look at high temperature situation, high temperature curing. You see, if I subject concrete to high temperature, that is concrete cast and cured at the indicated temperature, as you can see, that is, let us say at 30 degree it is cast and cured for 1 day, right, cured for 1 day at sorry, this is 30 degree centigrade, right, it is cast at 30 degree centigrade and cured for 1 day, you will get this strength. It is cast at 50 degree centigrade and cured for 1 day, you will get this strength. Same concrete at 3 days, you will get this strength, 7 days and 28 days. Now, you cast at 20 degree centigrade, this is 10, 20 would be somewhere here, and you find that the strength here is nearly the maximum. So, if you cast a concrete at higher temperature, I mean cast and cure at higher temperature, especially cure, of course, the casting has also effect. We do not really recommend casting of concrete at high temperature, similar reasons basically. So, cast and cure the concrete at high temperature, what happens is initial strength is high, but later strength is low. Up to 20 degree centigrade or around 23 degree centigrades, perhaps this strength is relatively high. Beyond that, if you increase the temperature, well, it does not show you high strength at 28 days. And if long term, in other words, we can conclude from this that if you want high early strength, you can go for high temperature, but you want high long term strength, high temperature is no good, maybe up to 23 degree centigrade is good enough, 23 degree centigrade is good enough. So, high early strength if you desire, then you can do high temperature curing, but at the cost of long term strength. This is because the hydration process, which is a chemical reaction and favored by high temperature, it is non-uniform when you do at high temperature. In fact, this effect will be very pronounced if you cast the concrete at high temperature. Curing after few hours of casting at higher temperature still is better than casting and curing at the same temperature. So, this gives you the compressive strength in MPa as seen here. So, concrete should be cured at high temperature. Casting, of course, beyond a particular temperature we do not really, nobody recommends that. You just based high temperature concreting is done, but temperature is usually controlled. But curing you can do at high temperature to attain high early strength, but long term strength it may not be as good. So, this is where the role of steam curing comes. Steam curing gives you high early strength. A formula is there which is called maturity, right. So, when it has been observed that the maturity is defined as the sum total of temperature into the product of the time for which the temperature was actually maintained. For example, if you have 2 hours at 20 degree centigrade, so 20 into 2 plus say 8 hours at 80 degree centigrades, 8 into 80, that is the total maturity of the concrete which has been subjected to 2 hours of 20 degree centigrade in the initial period and 80 degree centigrade for next 10 hours or whatever it is. So, this assumption is made that if you have concrete with equal maturity, they will develop same strength. The strength is a function of maturity, and that is what a curve shown through this sort of curve. You see, this side is a maturity log scale degree centigrade days, and that side is the compressive strength. So, what you assume, if you have the same maturity, you will have the same strength. It has been observed that curve is something like this, there is log of maturity versus compressive strength, there is a kind of linear relationship follows beyond certain point of the maturity. So, that is the idea about steam curing. Now, this maturity is measured as T above minus 11 degree centigrade. Datum is taken as minus 11 degree centigrade, because below that the concrete will never hydrate, the cement will never hydrate, and strength of concrete development, strength development of concrete will not take place. So, this is the concept of maturity, and based on this actually steam curing is done, right. Steam curing is done based on this, and as I said that initially we do not prefer, it is okay, this diagram would show you what happens steam cured concrete at water to cement ratio of 0.5, curing immediately after casting, and again if you see this it will tell us that this is at 23 degree centigrade, this is at 91, this is at 85, etc., etc. This curve is for 85, corresponding temperatures are shown here, and this is at 21. So, this goes on increasing, this strength goes on, and this is age 72 hours. So, it is 3 days strength actually we are looking at, and this is at 54 degree centigrade, etcetera, etcetera. Now, if you go on increasing the temperature 85 degree centigrade, 91. So, beyond a point actually even the 3 day strength coming down. So, very high temperature is again not desirable. This is the effect of steam curing on water cement ratio 0.5, and this is applied immediately after casting. So, this sort of several results are available in literature, tests done by various kind of people. The idea followed from this is of course, the steam curing cycle that has been recommended in many places is something like this. First 2 hours you do not touch, because if you heat up the concrete at that period of time, the overall strength development and as well as other properties of concrete, performance of concrete in the long term will be affected too much. So, first delay period, first about 2 or 2.5 hours, I mean when maybe 3 to 4 hours you have a delay period. Then of course, you heat it up through using steam, right, and temperature increases. So, this is the heating period, steam is circulated usually through pipes or even through a cover, you just put a cover and steam is just circulated through pipe within that cover. Even people use tarpaulin covering the element in precast industries especially, and then supply steam just below the tarpaulin. So, it will just steam is just passed on to the surface of the concrete. So, this is heating period, temperature increases, maintain this period, maximum temperature period for about 7-8 hours. You see, for example, 5 to it would be around 7 hours, that 7 and 7 to about 20. So, about 13 hours this has been maintained. It could be different depending upon the situation, it could be different the maximum temperature period, and then you allow it to naturally cool. So, it naturally cools, of course, it will rarely come to 20, it will be asymptotically going down to 20 over a long period of time, but it would require at least 7-8 hours to come down to the close to the ambient temperature. So, based on the fact that if you use too much of high temperature during the early stage of concrete, its long term properties are affected, long term performance is not good if you heat it up. And but if you want high early strength, then you can use steam curing. So, therefore, high early strength, supposing you want to release the mold or you want to do pre-stressing, steam curing can be a good solution. You want to place the precast element right onto the, erect it straight away very early in 3 days or 4 days time, or release its pre-stressing, release it from the pre-stressing bed. So, in such situation where you want high early strength development, steam curing is a good solution. In normal courses, it should not be, it is costly also, your investment would be there, the boilers and the steam generation system, supply of the steam, there are a lot of losses. So, all those part is there. So, therefore, steam curing is adopted where you want high early strength, and this could be the typical regime. Remember, if you do high temperature curing, this can affect the long term performances, right. So, that is all about curing. Let us look at the next part of our topic, that is prefabrication. Prefabrication refers to production away from actual site of construction. This refers to production away from actual site of construction, right. And idea is that you cast in one place and use it elsewhere, and use it and can be used elsewhere, right. You can use it elsewhere. What are the advantages? Advantages of precast concrete: you see, parallel activities first of all. That means, you do the casting, when you are doing the casting of, let us say, in case of a bridge, when you are doing casting of the deck portion, those could be beams or segments or whatever it is, when you are doing casting, you can actually construct the foundation. Normally, in cast in situ, what will happen? You will cast the foundation and then you can only cast the superstructure, substructure, cast the foundation, then the substructure, the like pier or something like that in case of a bridge, and then top deck after that. So, it is sequential, there is a technological sequence, but in precast you can do parallel activities. So, that is the biggest advantage. So, it can be very fast, it can be very fast, that is the first thing. Right, it is used in buildings, industrialized buildings. You can use them. For example, you can have all precast products, just bring them and assemble them, like steel or similar sort of material. So, reduce time, very fast construction can go on. Factory like situation, casting of concrete is done in factory like situation. Therefore, you can have really better quality control. All quality control procedure you can adapt, and therefore, it can have much better quality of concrete production. Then experience gained by the workforce through replicative, repetitive works. So, you repeat the same works time and again, and that means that experience is gained, and after some time it is all set, it is factory like. So, produced quality will be much better, everything is set. So, that is what is another advantage. Standardization is possible, you can standardize things, standardize the size, standardize the sizes, right, or rather you should use it where standardization is actually possible. You see, buildings are not necessarily same, look alike, but if you can standardize on certain things, it would be the advantages, big advantages. And there is something called modular coordination can be realized, which I will just mention later on. It may be economical in the long run, because you are producing same thing again and again. So, it can be economical in the long run. You can take technologically advanced industrialized construction practices, and this is reality in many countries in the western developed world, and robotics and similar sort of advanced technologies can be used in case of precast construction practices, right. Just this is an important issue, modular coordination we can actually apply here. Modular coordination is nothing but it is a set of dimensional rules, and it reduces the variability of dimension of building components. So, what you do, you have a basic unit, basic module, and everything is repetitive. So, your layout would be also modular layout, so that you can use one part, one component, you can use interchangeably the components, building components. For example, if the beam sizes are modular sizes, you can put in the modular grids. So, that becomes possible. Usually, you have got an unit which is called modular size, and it helps in industrialization. Industrial building construction relies heavily on modular construction. So, everything can be standardized really, dimensions and things like that. Well, so it can change to all kind of layout design easily. You should modular coordination does this job. Usually M 100 millimeter is used as a basic unit in some cases. Now, let us look at disadvantages of the precast construction. Well, if it is a building, then business sustainability is market dependent. If the market likes your product, there are examples where precast factories have been closed down because the market did not accept them. They can introduce monotony, because everything is same, replicates, several times you are producing the same thing. So, they may not they may not look aesthetically nice, especially in buildings, but architects can take care of this by various means. There are several other advantages of using this. So, if properly planned and designed, the monotony one can get rid of, but they can introduce. Third disadvantage, which is not been actually listed here, is the cost. You have initial high cost. So, there is a break even point beyond which actually it will become cheaper. Up to certain point it is never cheap. The plants types are permanent plant, field plant and fabrication on a building site. Permanent plant is the one particularly used in buildings which will sell components, walls, roof system, hollow core roof system, columns, linear systems, and then two dimensional systems. So, there are varieties of systems. So, permanent plant would be producing these ones which could be sold and erected at site. Field plants are used, let us say, for large bridges. Sometime you can have a field plant, and this would produce temporarily for maybe 4 or 5 bridges together. So, one after another, it could be field plant is of that kind, which is not totally permanent, but is quite, for some time it is permanent. And sometime for a single maybe estate or something of that kind, a building site, it is for project based, one project, the plant is there and then you dismantle it. There are 3 main groups of activities in prefabrication plant: main production activity, that is main concreting activity, auxiliary production activities, and managerial and technical general supports. Now, let us look at this activity situations. See, this line shows the basically main activities, that is concrete production, right, casting of elements, mixing of concrete, then preparation, and basically inspections, etc., then it is going out. So, this line denotes mixing, hauling of concrete, casting, and then hauling of the elements, then their inspection and any minor repairs required, and then of course, hauling of the elements, storage, and then it goes out. So, these are the main activity of a casting yard or a general plant. Now, if you can see, these are maintenance, materials testing, that is auxiliary units, then you have got preparation of the molds or reinforcement, etc., adaptation of the molds. So, these are the, if you remember the previous one, we said this is the main activities, this is the auxiliary activities, and this also is auxiliary activities, maintenance of equipment, etc., facilities, as is shown here, and this is the supporting activities like engineering, production, planning, accounting, etc., etc. So, 3 levels we mentioned earlier, these are the 3 levels in a general situation of precast, prefabrication casting yard or prefabrication plant, right. So, main functions of the prefabrication plant is shown here. The capacity would depend upon, there are several sequence, for example, mixing capacity, capacity of casting, capacity of hauling concrete, capacity of hauling elements. All this, the overall capacity of the system would depend upon the minimum of all. If Q1, Q2, Q3, etc., are the capacity of each individual components which are in sequence, the minimum will be, the overall capacity will be governed by the minimum. The best situation will be when Q1 is equals to Q2 equals to Q3 and all equals to Q. There are 2 types of basic systems, one is called stationary mold, other is called movable molds. See, this is stationary molds. So, my molds are stationary, as you can see, these are stationary mold situations, these are molds are stationary, this is stationary mold, and there is a overhead crane. So, the casting is done here onto the mold, the crane takes it out and then shifts it. So, this is called stationary mold. This is movable mold, where it is like an assembly line of a car or something of that kind, where this is workstation 1, workstation 2, etc., like this. So, the same mold moves along this direction, and then finally, for example, here the mold moves, maybe the reinforcement is placed, next it moves. So, it is on either on a rail supported, conveyor supported, basically the rail supported where the mold can move. So, as it moves at a given speed, here the reinforcement is placed, the concreting is possibly done, repair, inspection, etc., curing, and then it is actually heat, could be heat curing. Here is steam curing is very suitable thing, ideal thing. So, heat curing is done, then anything inspection, etc., and then it goes out. So, these are the other kind of principles that is possible, right. And but then movable molds, when you are doing, it is a fast process, it is a very fast process, it is highly industrialized situations, there you can apply, your planning has to be very good, engineering has to be really very good, right. Commonly used for building parts, industrialized building construction, high tech building constructions. Now, you see, there is one problem, since they are all in single line. So, if there is a disruption in any one point, whole system can get stopped. So, therefore, you have stations, you have stations like these stations, where if there is a problem, you shift it out, everywhere you have stations. Similarly, there are other arrangements. So, various kind of, there may be one in between, sort of a dummy station in between. So, if there is a problem, it can be shifted, other one can go on while this is rectified, and so on and so forth. So, there are various ways to tackle this, different arrangement for movable molds, right, can have continuous workstations, then provisions for reserve molds. The second one is the reserve molds, third one is the provision for site tracking. So, you have site tracking, fourth one is multi-purpose stations. So, many things can be done. So, this is taken care of by this problem of breakage, stoppage of the work due to breakdown is taken care of by this sort of arrangement. Right. The element handlings are generally done by mounted gantry, portal cranes, wheel mounted gantry cranes, overhead cranes, tower cranes, and mobile cranes, etc., etc. Okay, they are basic ideas. So, where they can be applied? industrialized building construction. Now, this is one place where it has found its big use, not in India of course at the moment, but you can produce at a very fast rate. Many countries, even countries like Israel or say in Northern Europe, Sweden, they have industrialized building construction system. So, it is very fast. If the concrete has to compete with the steel, because steel construction is very popular in many places, because you can just do it very quickly and erection is very easy. So, you have all pieces brought together and just erect them, weld them or do whatever it is. Now, if similar system can be replicated by precast concrete industry, and with the advent of high strength concrete systems and other development in concrete, this is a very useful thing. This can make things cheaper, very cheap in the long run, and production process can be very fast. I mean, the erection process can be very fast. So, you can get your house built in maybe one day, or in a 18-story building built in a month or two. There are other methods, but this is also a big advantage. Bridges, this has been used also in India right from 1970s, segmental construction of bridges. Piece you bring cast in casting yard, bring them up at the site, erect them and join them by pre-stressing or various means. There can be long line or short line casting. In short line casting, you cast one element and then cast the next element by the side of it, what is known as match casting, and then remove that one. But in long line, say complete one span, you will have molds placed in, the mold placed for the whole span, and then each elements are cast one after another together. So, that is what it is, long line casting. So, bridges, this has been used in India. I know Allahabad bridge over Ganga is recent bridge, is long line casting. Short line casting has been used in many. Ganga bridge in Patna is one of them. Many in Delhi flyovers, many of them are segmental construction of this kind. Railway sleepers have been used for many years, and many other miscellaneous items. Industries and sports complexes. So, these are the possible applications of precast industry. It's got big precast concrete, prefabrication in construction. If the concrete construction is engineered fully, then this would be very useful thing. But one has to remember that initial cost could be high, but after a number of them, it will break even. It will generally break even after a number of them. So, therefore, advantages are very much there, and in this one can take advantage of the high technology in the concrete material science, like high performance concrete, because they requires very good quality control, or other kind of development in cement based composites, other kind of developments in cement based composites, etc. One can actually take advantage of these situations. Right. There are of course things like sports complexes built in the country, like Kantirava Stadium in Bangalore. This is made of precast elements, the dome structures, its beams, etc. Those are precast. So, this has been already in practice. Industrialized building is yet to come, but they have their big advantage in terms of the fast construction. Okay, so that's about prefabrication and curing. With this, we generally conclude. To summarize the whole thing, we have looked into the curing, the methods, the need, the methods, and we have looked into the ill effects of not doing proper curing. Also, we have looked into steam curing. Then we have looked into prefabrications, basically what are the types of plants and advantages and disadvantages. I think with this we conclude.